chemistry. This is Miss Ruark. Again, like it would be anybody else. I know, so silly. Okay, we're going to talk about balancing chemical equations because you've got to balance an equation in order to use it. All right, so how do we symbolize molecules? Well, if we had chlorine gas, we would say that it's two chlorine molecules that are attached to each other, right? This would be a Cl and this would be a Cl. They would be attached to each other because they would be sharing those, going back to Lewis structures. Oh yeah, you guys love these. All right, because they would be sharing those electrons to make sure that they both have 8. Well, what if I had 2 chlorine atoms? Well, I would have a chlorine atom and a chlorine atom just floating around, right? So it would just be 2 chlorine atoms just kind of chilling. They wouldn't actually be chilling. They'd be very unhappy because they need that one extra, so they're searching. What if I had 2 chlorine molecules, molecules? All right, well, I'd have a chlorine attached to a chlorine, and guess what? I would have 2 of those. So what's my purpose for doing this? Well, how many do I have here? I have 2, right? 2. How many do I have here? Well, I have 2. How many do I have here? Well, I have 2 times 2 is 4. 1, 2, 3, 4. Right? Well, that's going to be important when we balance equations. So let's review this. We've already done this before, but we're going to review it anyways. How many of each atom are in the following? So how many NAs do I have? I have 1. How many O's? 1. How many H's? 1. That was easy, Ms. Ruark. I know it was. So let's do this next one. How many calciums do we have here? Well, we only have 1. And if some of you are like, how does she know? Well, remember, if nothing's written, we assume it's 1. All right, well, how many oxygens do I have? Inside the parentheses, I only have 1. But look, there's a 2 out here. So we have to multiply this by, and I shouldn't have drawn it that way. That's right. We have to multiply this by everything that's inside the parentheses. And if we're multiplying by everything that's inside the parentheses, that now gives us 2 oxygens, and it gives us 2 hydrogens. All right, well, we now have calcium, oxygen, and hydrogen again. We have one calcium here, but we have to multiply it by this, so that gives me 3 calciums. All right, we said in this previous one that we had 2 oxygens, but guess what? We have to multiply it by the coefficient, which gives us 6. And this here gives us 2 hydrogens, but we have to multiply it, which gives us 6. Okay, we're going to practice this for a long time. You got it. Oh, no. Oh, sad face. Let's start that over again. Sometimes my pens just don't want to work. Okay, balancing equations. So the law of conservation of mass says that matter cannot be created or destroyed. Atoms are only rearranged in a chemical equation. Okay, so they just change form. So the number of particular atoms on one side has to be the same as the atoms on the other side. So for example, here we have magnesium and we burn it in the presence of oxygen. And hey, guess what, guys? If it's burning in the presence of oxygen, it has to be a combustion reaction, but because it's 2 things that are coming together, we could also say it's a synthesis. So yes, you can classify these as more than one reaction. Okay. We have magnesium and oxygen on the other side. That's good. We want to make sure we have the same atoms on each side. Well, the next question is, do we have the same number of atoms? Well, we have 1 magnesium over here, and we have 1 magnesium there. Yes! We're done. No, we're not, because we have oxygens. We have 2 on this side, and we only have 1 on this side. So this isn't balanced. We need to balance it. All right, well, let's talk about how do we balance it. Well, we can balance equations by inspection, which is usually one of the ways that we'll do it most often, especially if it's an easy equation. You start with the elements that occur in one compound on each side. You're going to treat polyatomic ions as if they are the same, and I'll show you what I mean in just a minute. But if an element is completely by itself, you want to try to leave that for last. All right, so on this one, letter A, we have P4O2 gives P4O10. Okay, phosphorus, there's 4. Phosphorus, there's 4. It's good. Oxygen, there's 2. Oxygen, there's 10. Now, when we balance these equations, the only thing that we have the power over changing is the coefficient that goes in front. We cannot change the subscripts. We cannot add atoms. We cannot subtract atoms. So if I've got 10 here and only 2 here, what number can I put in front of the oxygen that I can multiply by to give me 10? And I can put a 5. And now we're balanced. Check. Moving on. All right, lithium, we have 1 Lithium, we have 1. We have water. Oh, but then on this side we have hydrogens and hydroxides. Ugh. Mr. X said treat your polyatomic ions as if they are a single entity. So if I have the same polyatomic ion on each side, I can use them as one thing. Well, the nice thing about water is we can break that apart. Anytime you have hydroxide on the other side, you can take water and break it up into HOH. Oh, it makes it so much easier now. One lithium, one hydrogen, 2 hydrogens. So we need to put a 2 here. 2 hydrogens, 2 hydrogens. All right, 2 hydroxides, because the 2 goes to the hydroxide. Here we only have 1 hydroxide, so we need to put a 2 there. To balance that out, we come back here and put a 2 in front of our lithiums, and now we're done. Okay, so keeping the polyatomic ion together does make it easier. If it confuses you at first, you are more than welcome to keep them, break them apart. All right, I'm going to keep them together just because it makes it easier for me to go faster too. Okay, bismuth. We have 1 bismuth, we have 2 bismuths. So let's put a 2 here. The bismuths are good. All right, here I have 3 nitrates, but I've got to multiply it by 2 here in the front, which gives me a total of 6. So on this side, I have 1 nitrate. I have to multiply it by 6 to give me 6 nitrates. Now we're okay. All right, here I have 2 potassiums. Here I have 6. So I'm going to put a 3 here. And then that gives me 3 sulfurs and 3 sulfurs, and I'm done. Okay. All right, C2H6, 2 carbons, and we have 1 here. So we're going to put a 2. Here I have 6 hydrogens, and I only have 2, so I'm going to put a 3 to give me 6. All right, that gives me 4 plus 7. Ugh, 4 plus 7, or 4 plus 7. 4 plus 3 gives me 7. Okay, now if I have 7 oxygens on one side and I have an even number or 2, 7 and 2, only 2, then what you're going to do is you're going to come back through and you want to multiply this whole thing by 2. Okay, well, let me take a step back. If I have 7 and 2, what you're going to do is you can't, because this is a package deal, you can't break them apart. You have to have a double of everything. But I can't put in front of this a decimal because a decimal doesn't work. 3.5, it's just not going to work. But I can take this number that I need and put it over the number of the subscript, so 7 halves. 7 halves would be the same thing as 3.5. It would give me 7. Okay, well, I can't have a fraction, so I've got to multiply everything by 2. And that's why I just said multiply everything by 2. So that ends up giving me 2. That gives me 7. This changes to 4, and this changes to 6. Don't worry, I will explain this in class. We will go through many practice problems. Okay, balancing by atom inventory. So on this one, you're going to actually make a table that's going to keep track of your atoms, and we'll practice this way as well. Most of you will probably do this way until you get the hang of it, and then you'll probably start doing balance by inspection. All right, so to set up the table, underneath my arrow, I usually write down every single one of the elements that are involved in the reaction. Okay, and then I go through and I count. I have 1 Mg, 1 H, and 1 Cl. On this side, I have 1 Mg, 2 Cls, and 2 Hs. Okay, so now my Mgs are balanced. My H's are not. I need more on the left side. So in order to get more on the left side, if I have 1, I have to put a 2 here to multiply. 2 times 1 gives me 2. So I can change that. But it also not just affects the hydrogens, it also affects the chlorines. And guess what? Now we're balanced. See how easy that is? It's so easy. So easy. All right, so here's some for you to practice on. I'll do the first one with you, and then I want you to pause it and come back and check your work so you can see if you're actually getting these or not. And we're going to balance, balance, balance until you're tired of balancing. Okay. All right, so here, calcium and nitrogen, so Ca and N. We have 1 calcium and 2 nitrogens. We have 3 calciums and 2 nitrogens. My calciums are unbalanced. I need 3 on this side, so I put a 3. It's so easy. Okay, go ahead and pause it. Come back, check your work. Okay, here we have Bi, we have Cl, we have H, and we have S. There's 1, 3, 2, 1. On this side, we have 2, 1 chlorine, 1 hydrogen, and 3 sulfurs. All right, I always start on the left side and just move my way across. You don't have to. You do it however you want, but that's just how I work. Okay, BI, we have 1 on this side and 2 on this side. So I need to put a 2 here to cancel that out. That gives me 2 bismuth, but it also changes my chlorines to 6. All right, I've got 6 chlorines and 1 chlorine on this side. So if I put a 6 here, it gives me 6 chlorines. It also gives me 6 hydrogens. Still good so far. I've got 6 hydrogens and 2 on the other side. So if I put a 3 here in front, where did my arrow keep going? There we go. If I put a 3 here, that's going to give me 6 hydrogens and it'll give me 3 sulfurs. And now I'm balanced. Okay, now a common mistake that students make is they balance it down here, but they don't add the coefficients in up at the top. This right here is your work. That's all that is. That's your work. And you don't actually have to show your work. It just helps so that I know where you're at. A lot of times if you're doing balancing by inspection, you're not going to show your work. But this is the balanced chemical equation. This is what I'm looking for when I check your work. All right. On the next one, go ahead and try it and then come back and check your work. We have N's, we have H's, and we have O's. On this side, I have 2 N's, 4 H's, and 3 O's. On this side, I have 2 N's, 2 H's, and 2 O's. Okay, my N's are good, my H's are not. So I'm going to put a 2 here, which gives me 4. That also gives me 2 plus 1 is 3. So easy, I know. All right, try this one. Come back and check your work. I have 4 carbons, 10 hydrogens, and 2 oxygens, 1 carbon, 2 hydrogens, and 3 oxygens. Okay, always leave oxygen for last. If it's by itself, leave it last. Okay, a lot of people like to jump in with oxygen first. You're going to be here forever. All right, 4 carbons. So that gives me 4 carbons. It also changes. I have 8 oxygens plus 1 is 9. I have 10 hydrogens, so I need to put a 5 here. That gives me 10 hydrogens. 8 oxygens plus 5 is 13. Okay, look, we have 13 and 2. So we take and put this number over that number, so 13 halves. How do I get rid of a fraction? Well, multiply by the coefficient, or by the denominator, right? The whole thing gets multiplied by 2. So we've got 2. This becomes, I'm going to change it and put it in a different color, 13. This becomes 8. And this becomes 10. So it should be 2, 13, 8, and 10. All right, guys, that's it. So I'll see you in class. We'll practice more.